Okay, this is section 3.6, the math of finance. And we're going to start with some of the basics of compound interest. And um, the next lesson, we'll get into more advanced ones. So for our basic thing, we're talking about either a loan where we just see how much interest it gains over time, no payments on this, or we're talking about a deposit where I deposit a certain amount and I never touch it, I never add to it. Now, realistically, we often make payments on our loans. We add more to our deposits. But for this purpose, we're going to start with the basics, and we are going to um, go from there. So my basic formula, A equals P 1 plus R to the T. This would be compounded for whatever unit of time. Usually this would be compounded annually, and unit of time would be in years. P stands for principal. You might also see this as A sub 0, or that means the amount put in at 0 years. So this is my basic one, compounded annually. If I want compounded more than annually, say I want compounded monthly, N is how many times I'm compounding per year. R stands for my interest rate. It has to be as a decimal. So if I have 4%, that's 0.04. T is time, pretty much always years. N is number of times I'm compounding per year. So if I want to compound my interest monthly, that would be 12. If I want to do it quarterly, that's 4. If I want to do it daily, that's 365. Don't try to get too technical. Weekly is 52. And P is principal or initial amount. That's why we can call an A0 just means initial A, and A is amount that we have. If you look at the book, they use a different variable. They use K instead of N. It's the same thing. I always used N, and that's what's in the formula packet. So, okay. So we'll do a couple examples with this. Really, if you know this formula, if N is 1, you just get rid of it or put in a 1. It doesn't change anything. And we will always do the calculations part on a calculator. So suppose Quan Lee invests $500 at 7% interest compounded annually. Find the value of her investment after 10 years. Always a good idea to write down what you have. P is 500. My rate, 7% is 0.07. And I'm asked for the value after 10 years. And it asked me for the value. So I can say, put in my equation, 500, 1 plus 0.07 to the 10th. And I take a calculator. I plug that in. 100. Sometimes I'll just enter 1.07. I'll just do that addition. Oops. I didn't mean to hit enter, but I'm going to hit second enter. Wasn't what I meant to hit either. Second enter. That'll bring me back to my equation. And I get 983.5758 if I round it correctly. And that was example 1. Relatively straightforward. And make sure you put dollar signs on this because this is in dollars. So now let's do the same thing, but we're going to do 5 years compounded monthly. So now I know N compounded monthly is 12, and my time, same, well, actually it's Roberto. Pretty much the same investment, but okay, I didn't want to do that. So example 2 is almost the same thing. We'll do it in a different color though. But it's going to be Roberto, and he's got a little bit better interest rate, and he's got it compounded monthly. Roberto's got a 9% interest rate. These are really good interest rates, by the way. Compounded monthly, but he's only going to have his in for 5 years. I'm guessing even though he's got the better interest rate, the less years will make it less. So 1 plus 0.09 over 5. Really important that the 5 come to the exponent, not over 5. It's over 12. Over 12 for monthly. It's really important that this 12 makes it to the exponent as well. So the 12 is in both spots. They're always the same. And his amount is 782.84. So no, his only having it for 5 years hurt how much he had. So he had less than Wanli, even though he had a better interest rate and compounded monthly. Finding the time period on an investment. Example 3. Judy has $500 invested at 9% annual or monthly, compounded monthly. How long will it take her investment to grow to 3,000? So I'm looking for 3,000. My principal, again, 500. They like that amount. This is example 3. My rate, still 9%. That's great. And is 12. I'm looking for my time this time. Okay, I'm gonna do a combination of solve by hand and solve by graphing on this. Um, you could solve by hand, it would involve a logarithm. But to simplify my graph and my finding units, I'm gonna just do a little part of doing it by hand before I solve by graphing. So I'm gonna divide by 500. Part of the reason I'm doing this is because it makes it's a really nice number on this one. Okay, so now I've got 6 equals. So I'm gonna put in y1 is gonna be 6, and y2 is gonna be the other side of my equation, the 1 plus 0.09 over 12. Actually, it's got to be 12x always on your calculator. So let's go to the calculator. Let's solve this by graphing. Oops, I can't do 1.09 on this because of the divided by 12. I keep thinking backspace will give me delete, but it does not. I'll just type right over that typo. To the power of 12 times x. I should be able to get this in a normal zoom. Oh, wait. I forgot my 500 was divided away. Now I should be able to see this. And it's not in the normal zoom. So I'm just going to make my x, and we're going to go up to 50. We'll do a scale of 5. Now, when I find the intersection, that will solve it. I'm on my blue curve, I'm on my red curve. I guess it's the only one. 19.98. Basically, it's going to take 20 years for this to accumulate to $3,000. Although that is 6 times the value I started with. So that's a pretty good amount of interest, 6 times as much. But it does take 20 years. Okay, we're going to move to example 4, where we're going to find the interest rate that's needed to get to a certain amount in a certain amount of time. So Stephen has $500. He wants what interest rate compounded quarterly is required to double his money in 10 years. So P is 500. Doubling that would be 1,000. Doesn't specifically tell me that number, but I can double 500. It asks me what interest rate, so I don't know what that is. I know it's compounded quarterly, so N is 4, and I'm told 10 years. Again, this is definitely going to be a solved by graphing problem. So I'm going to plug it into my equation. 1,000, 500, 1 plus r over 4 to the 4 times 10. Again, I'm going to divide by 500 first. And you get something that anytime you're doubling, it doesn't matter what the initial amount is. 4 times 10 is 40. Doubling is going to be 2, and I can pretend my initial amount is A. So if they hadn't given me this, I could say 2p equals p 1 plus r over 4 to the 40th. And I can divide both sides by p. Doesn't matter what the initial amount is, I still end up here. So I'm going to go to my graphing calculator with this one. Two. And I can just edit these. And it'll probably show up on my graph here. Oh yeah, it's going to show up. So I know my interest rate is not negative. So you see here on the graph, I see a bunch of negative stuff. And And this kind of looks pretty bad right now. But I see a bunch of negative over here. Really, I know my interest rate is between 0 and 1. Yeah, nobody's giving an interest rate close to 1. So I have to set my window appropriately. Let's get rid of this scribble in the middle of the screen. So I'm gonna put my minimum at 0. My maximum, I think I'm only gonna go to 0.5. And my y's should be fine to 10. So yes, it's less than 0.1. I'll find my intersection. Really important though to do when you're doing these that you get a view that looks and shows you something. 0.0699, 0.07, basically 7%. I guess they gave 3 significant digits. And it doesn't round up. So 6.99%. He's going to need to get at least 6.99% to double in 10 years. If he gets 7%, he's there. If he gets 9%, he's more than doubled. Okay. The last thing we're going to talk about for today is compounding continuously. So that means more than every second. That means every whatever, every hundredth of a second, continuously uses our number e. Okay. And so we get the equation A equals P e to the RT. Okay, this is a nice, clean, simple formula. Basically, it's my other formula, and E somewhere I've shown you this with a limit, but it's a E is basically 1 plus 1 over infinity to the infinity. And so I'm kind of replacing this 1 plus R over N to the NT with E to the R. So applying that, Latasha invests $100 at 8% annual interest compounded continuously. Now, the percent, they're always going to give you the percent annual interest, or what it would be if you literally just did it once a year. Basically. Basically, that's what they're always going to give you. If it says percent annual interest, that's just R. So A is what we're looking for. And we're actually looking for it over 1 through 7 years. And I'll show you how to do that on the calculator. So she invests $100. R equals 0.08. And T equals 1, 2, 3 to 7. So my formula is A equals 100. E, remember E is the number E, 0.08 X is what I'm going to enter in my calculator. I'll go back to my Y equals 100. I use the E to the X button every calculator should have an E to the X button. It just takes me straight to the button. Some people, you can use the E button and then do the power of, but I like the E to the X button. It saves me a step. 08X. Now, to get all these values, instead of graphing, I'm going to use the table. But to set up the table, I need to go to table set, which is second a window. I'm starting at 0. That means the first number in my, it's going to functionally give me like an XY table. That's going to look something like this, and it's going to do Y1. And delta table is going to be how much does each, so this little line here, how much do I increase by? Do I want to go by halves, twos, threes, fours? So this one looks like it's set up perfect. The default tends to be that. Okay, so year 0, we got 100. Year 1, 108. Year 2, 117, 35. Year 3, 127, 12, etc., etc. Year 7, 175 and 7 cents. Okay, that is 3.6 part 1. We'll do part 2 tomorrow.